Nowadays, the internet has become an important part of our life. We use the internet to search any information, including directions, jobs, social events, and more. Shanji Levy was an intern at the Federal Bureau of Prisons in Washington, D.C., who disappeared in May 2001. Computer investigators who examined Levy's laptop computer determined that the laptop was used to search for the location of a historic house in Rock Creek Park. This was Shanji Levy's last search. Her skeleton was later found in Rock Creek Park. Searching and examining a suspect's web browsing activities are a crucial step in forensic investigation. Forensic examiners usually search through web cache and history files to collect information such as the URLs that a user visited, cookies, pages downloaded, and the time of access. Before IE 10, the IE stored user browsing history in an index.dat file. The location of this file varied based on the OS. Since Explorer IE 10, this information is stored in a central database located at C and in a web cache directory. Both NCASE and FTK support Internet history viewing for all well-known browsers to reconstruct a subject's Internet activity. They can also search browsing activities from unallocated space. The free tool, Pascal, which means browse in Latin, was developed to pass the index.dat file and output the information in an index.dat file. Pascal will execute on Windows through Cygwin, Mac OS, Linux, and other BSD platforms. For Firefox, the Internet history, file downloads, cookies, and forms are stored in .SQLite files. Safari stores Internet history, bookmarks, and download information in .plist files, and stores cookies information in .binary cookies. Please be aware that if a user enables private browsing on web browsers, some of the browser history may not be available. Privacy protection tools such as Trax Eraser Pro or CCleaner may also delete browser history. Now let's look at what evidence a printer might leave behind. Printing involves a spooling process. The local print provider writes the file's contents to a spool file, .spl, by creating graphics file, .emf, for every page. It stores printing metadata in a shadow file, .shd. It then saved both the spool file and the shadow file on a local disk to protect a print job until a printing process completes. Therefore, for each print job, two files are created. The shadow file contains information about the print job, such as the owner, the printer, the name of the file printed, the fully qualified pass, and the printing method, in our case, the EMF. The spool file contains file contents in .emf pictures. Shadow file and spool files are deleted after the print job completes. However, these files may still exist in unallocated spaces or Windows memory page file. Data carving techniques can be used to carve out the EMF graphics from spool files. Recovering printed files provide forensic examiners additional evidence for investigation. Jump lists are a new Windows 7 feature that provides the user with quick access to the documents and the tasks that are frequently or recently used. On the taskbar, jump lists appear for applications that you have pinned to the taskbar and applications that are currently running to provide you a list of recently accessed documents or frequently accessed destinations, depending on the application. For example, if you open two Microsoft Word files and then right-click Microsoft Word icon on the taskbar, you will see these two documents listed. By default, jump lists show the 10 most recently accessed file or frequently accessed destination per application. Forensic examiners are particularly interested in information stored in jump lists. This includes the full path to the target file or directory, along with the MAC times, the computer name and the MAC addresses the target file resides, the last access date and time, and the application used to open the file. There are two types of jump lists: automatic and custom jump lists. The automatic jump lists located in user profile and under automatic destinations are created automatically by OS when a user launches applications or access files. These files follow a compound file binary format with link information embedded. Custom jump lists located in user profile and under customer destinations are created when a user pings an item. These files are link format streams appended to each other. There is more information about jump lists in the resource section of this unit for those interested. Why is this artifact important for forensic analysis? From the forensic analysis perspective, the existence of automatic jump lists is an indication of a user activity on the system and provide investigators with a valuable proof that a user accessed a file. Also, even if the files have been deleted, they are still included on the jump list. The full path information of the deleted target file may lead investigators to identify more evidence. Here is one scenario. A jump list contains information about a Word file stored in a USB stick. The investigator obtains proof that the suspector accessed this file with the name of the file, its full path, as well as the date and the time of the last access. Now the investigator can request or search for this USB stick to recover more evidence. Jump list analysis is important for solid-state drive analysis, allowing investigators to discover files' existence on the disk after the file has been wiped through SSD garbage collection process. Windows also has other artifacts such as shadow copies, Windows prefetch, control panel, shell bag, and others that are important for forensic investigation. The SANS post in the resources section provides a brief overview of the artifacts and registries that help Windows forensic analysis. If you are interested in learning more details, please read a couple of slides in the appendix part of this set of slides. Now let's move on to the next important topic, event logs. Windows stores various events in 3 event logs in a binary format: SEC event, sys event, and app event. Windows Event Viewer is used to read these log files. Application logs in app event contain events logged by programs or applications. For example, a file error logged by a database program. The events that are logged and the amount of detail provided are determined by the application developer. System log contains events that are predetermined by the system server and logged by system components. An example of events can be failing to load a driver. Both the application log and the system log show 3 different types of events: error, warning, and information. Security log records security events such as login, file accesses, or modification attempts as successful or failed, depending on what was requested to be audited. These events are controlled by the auditing functions of the various resources and the subsystems. By default, these events are not recorded. Security logs are only viewable by administrators. For example, Windows logs successful user logon, logoff, or failed logon, logoff events under the security event log. For certain operating systems, the event ID of 4624 indicates a successful logon. The event ID of 4625 means a failed logon. The event ID of 4634 indicates a successful logoff. And then 540 means a successful network logon. Please be aware that sophisticated attackers may alter event logs by selectively editing or deleting entries to hide their malicious actions. An investigator should always be vigilant about the malicious actions and look for inconsistent evidence.